At Greenwell Professional Services, we invest heavily in our graduate schemes, but want to ensure this money is spent effectively as possible, since competing for and developing high potential young talent is critical for the future of the business. We want to ensure that the strategy is effective at producing high performers, so I need to see what factors are most associated with high performance in the first year. To do this, I need access to talent insights powered by Watson Analytics, a powerful cognitive workforce analytics application that understands natural language and can build predictive analytics in minutes. In order to perform the analysis, I need to first prepare a data set on our graduate hires from our applicant tracking and also from my talent system in terms of how they performed in their first year. So I load my data into the system and use natural language to ask a question. I want to see first of all a breakdown of the target group, graduates, by first year performance ratings, so I type the question. Talent Insights then reasons with the data and suggests a high level of confidence in the larger boxes at the top, so I select the tree map to produce the visualization. By adding top 10 university as a row, I can now see the differences between graduates that did or did not attend a top 10 university in terms of first year performance. In order to see a percentage, I simply change the bar chart and stack to show percentage, and can clearly see there's a big difference in the percentage of top performers from graduates that recruited from a top 10 university than those that weren't. Likely this isn't the only factor at play, and we also spend a lot of money on our campus recruiting events like the Milk Round. I want to see if this is also an effective strategy, so simply ask another question, but keep my previous visualization for later to add to my dashboard. Whilst Milk Round does appear to be the best method for attracting high performers, the difference is less pronounced, but this is definitely something we want to investigate further. I also want to see the effect of A-levels, and by clicking on the keyword I can change the recruit source to A-level attainment. Here it seems whether or not someone got 3 A's or less has a negligible impact on whether or not somebody is likely to be a first year high performer. But what about other factors? By clicking on the field name, Watson doesn't just give me an A to Z list, but suggests those with the most interesting relationships, one of which appears to be cognitive ability. By selecting this, the picture changes dramatically, and all of the candidates in the top band for cognitive tests also became high performers. This is really interesting, and seems like a much better predictor of on-the-job success than A-level results. Maybe we could even stop looking at substituting A-level questions in our applications with a cognitive test. Finally, I would like to see how all of these factors play out together, and turn to my predictive tool, which helps me understand the relative importance of all of these factors in driving high performance. I create a new workbook and let Watson do its work. I don't need to know which statistical model to use, as it will select the correct ones for me automatically, and much of the statistical heavy lifting is done in seconds that could have taken my data scientist hours or days. I immediately see the top predictors of high performance are cognitive ability band, previous intern experience, and degree attainment. Looking closer at the cognitive band driver, I can see through clear visualizations that 75% of graduates that scored in the top band of cognitive ability also scored highest in their first year performance review. This is valuable information for both the business to keep investing in the assessment program, but also our hiring managers that often recruit based on gut feel or likability in the interview. By looking at how all these factors play together, Talent Insights builds a much stronger predictive model, and again, intuitive visualizations help me see the relative importance of each factor. Cognitive ability seems to be the most important in predicting first year performance, but whether or not you went to a top 10 university, the method of recruitment and degree attainment all play a part, as well as other factors. Finally, the decision tree helps me understand the factors that might shape our graduate recruitment strategy, and I can see that our Milk Round on campus recruiting method, candidates must have a 2-1 or above. If less than a 2-1, they must also have been to a top 10 university in order to get a high performance score in their first year. All of these findings have come in minutes, but will be valuable to our business leaders when justifying the effective methods for ensuring a pipeline of strong future performers. To tell this story back to the business, I need to compile a dashboard with my findings, so I simply start a new dashboard and use the infographic template to build the story. The insights I've found along the way have been pinned to my collection, allowing me to easily drag them onto my workspace, and each exploration becomes its own interactive chart. So to conclude, we've discovered that whilst we had previously assumed A-levels and degree attainment were the most important drivers of graduate performance, we now find that cognitive ability is by far the most important predictor. We also know that continuing to invest in our Milk Round and on-campus recruitment strategy is an effective method for sourcing. However, care must be taken not to place too much emphasis on candidates from top 10 universities, since those that are hired through on-campus events still manage to attain a 2-1 or above seem to perform well, perhaps because we have taken more care to engage face-to-face with the right potential. For more information on this powerful tool for workforce analytics, please contact your local IBM representative.